The second type of cubic graph is of the polynomial form, and it is of this general form: ax cubed plus bx squared plus cx plus d. And we must factorize this polynomial into 3 factors, and this will give us the intercepts on the graph. Now let's have a look at the first 3a as an example. So you've got x cubed plus 2x squared minus x minus 2. So the first thing we do, we substitute a value into the equation. Substitute a value into the equation in order to make it equal to 0. So I guess a value of x that will make this equal to 0, and they'll give us the first factor. So we try the most simplest one first. So first of all, I'll put the equation into the fx form. So it's indicating I'm going to substitute the value into there. So I'll try 1 first of all, and you can see it's going to be equal to 0. So 1 cubed times 2 times 1 squared minus 1 minus 2 will give us 0. So that means that x minus 1 is a factor. So with this x minus 1, I'm going to divide it into the original equation. Okay, using long division. This might look tricky, but it's not really that hard. It just takes a bit of time to nut it out. The first thing you ask is, what must I do to the x to make it equal to x cubed? Well, I must multiply it by x squared. Then I multiply through by x squared, so I get x squared times x gives me x cubed, and x squared times minus 1 gives me minus x squared. Then I'll change the signs, because I must take it away from the top line. So if this is x cubed positive, so I'll make it negative, and this is negative x squared, so I'm going to make it positive. And it's just easier. I mean, all we have to do here is eliminate x cubed with x cubed. That gets eliminated. And here we're going to add those two together. So it's plus 2x plus, you'll get 3x squared. Then we bring the next term down. Then I ask, okay, what will give me 3x? What do I have to do to the x to give me 3x squared? Well, I must multiply it by 3x in order to get 3x squared. So, and then I multiply through. It's 3x times 3 times x gives me 3x squared, and 3x minus 1 gives me minus 3x. Again, the next step is to change the signs. So this is positive, I'll change it to negative. This is negative, I'll change it to positive. So whatever sign there is, I will make it opposite. They cancel, and then we add these two together, that will give you 2x. And just like with long division, bring the next term down. And again, I ask, what do I multiply the x by to get 2x? Well, I have to multiply it by 2. So 2 times x gives me 2x, and 2 times minus 1 gives me minus 2. Then I change the signs again. So minus, plus, and you can see they will cancel each other out, and you'll get no remainders at the end. So now our equation is equal to x minus 1 x squared plus 3x plus 2. So this second part is a quadratic, and that's, we can factorize that. We know how to do that. Remember what two numbers, when multiplied, give you 2, and when added, give you 3. It will have to be 2 and 1. Right, so once we have factorized the equation, we've got the intercepts. The y-intercept basically is just the constant at the end of the equation. And how we get this, basically, if we let x equal 0, then the first three terms will drop out, it will be 0, and so our y-intercept in this case will be -2. So we can proceed to draw the graph. Right, so we have our intercepts as that 1, -1, and -2, and it will cross the y-axis at -2. That's 1, -2 here. Right. So we proceed to draw the graph. Now, it doesn't mean the turning point will be at -2. The turning point, it looks like it will be just before -2, but we're really not sure whereabouts it is. So we need our graphics calculator to show us where it is. Or we can also calculate it using calculus, but that's later on. I'll show you in another video how to do that. And then it goes down, it crosses the x-axis at -2 again. So where it crosses, whereabouts it turns, right? So we need our graphics calculator to determine that. So if we put the equation in, just want to clear that, and we put the equation in, it will be x cubed. Any graphics calculator will be able to do this, plus 2x squared, so minus x minus 2. Oops. Right. And then we can graph the function. And so we can determine whereabouts the turning point. So you can see the turning point is much different on the graphics calculator than what I have drawn here. So it's a little bit lower to what I've shown here. So it's important to know whereabouts they turn. Those intercepts won't actually tell you whereabouts they turn. So here, this is where we need to use the graphics calculator. Right, that's no problem. We can determine the where in the first case is the minimum, where the graph reaches the minimum. Calculator worked that out for us. Right, it's calculating the minimum. So the minimum here occurs at -2.11. So that's correct. It turns before it crosses the y-axis. So I'll just write that down. It'll turn at x equals 0.22, and y equals -2.11. So at x equals 0.22 and at y equals -2.11. Okay, and so the maximum, we want to determine whereabouts the maximum is. Right, so number 4. Again, it's calculating whereabouts the maximum is. So the maximum occurs at where x equals negative 1.55 and where y is equal to 0.63. So the maximum occurs at negative 1.55 and y equals, what did it say? 0.63, 0.63. So this is where the maximum occurs. Right, this is max, and this is the minimum. So if I was to draw that properly, then it would look more like this. And that's probably right on that side. Okay, it's turning very little there. Okay, so that's more accurately drawn.